So this is what exactly happens inside the lift. How the weight changes whenever the lift goes up or goes down. So here in this example, there are two persons. One person is inside the lift, person A, and the person B is outside the lift. The person B is actually in the inertial frame of reference. This is what we call as inertial frame. As it is in the rest frame, and the person A is in the non-inertial frame of reference, where we have to apply the concept of pseudo force to bring the equation of motions. Now, whenever the lift starts moving in the downward directions, so what exactly is going to happen? So we have taken an object here, and the object is placed on a weight machine to see the change in the weight. Now, when the lift has not started its motion, so if I talk about with respect to person B, whatever I'm drawing, this is with respect to person B now, inertial frame of reference. This object will have two forces. One is upward force, that is the normal reaction force, and the downward force, that is its mg. So this equation R becomes equals to mg when the lift is not having any velocity, or maybe the lift is having the constant velocity. Constant velocity means whenever the lift is in between the two slopes, right? The lift just starts its motion, starts accelerating and reaches to the constant velocity, then starts decelerating and then stops. For example, if I play this video, here I'm going to take the weight of my mobile phone, which is showing 206 grams. This is the real weight of the mobile phone. And now we are inside the lift. And the lift is not started its motion yet. We are measuring the weight again on the floor of the lift, which is showing exactly equal, which is 206 grams, as you can see. Now, I'll start the motion of the lift. We already have started the motion of the lift. As you can see here, the change in the weight, it has already reached to 200, right? It has already reached to 200. You can understand this one. You can understand it reaches to 199 now. I hope you can understand this value as reaches to 199. So when the lift goes down, so you can understand the weight decreases. So how the weight is decreasing, let me explain it. So when the lift is going down with an acceleration, just starts its motion and going down with an acceleration. So what exactly is happening? The same thing I'm going to draw here. This is the object. Now the lift is accelerating downward direction. So it's the mg, it's the normal reaction force. So with respect to the frame of reference, inertial frame of reference, person standing outside, what is going to be the equation of motions? So here definitely the mass of the object, say it's m. So mg minus r, as it goes down, is going to be equals to mass into acceleration. So what is this value of r finally? Because this mg is going to be greater than r, and that is equals to net force on the body, that is m into a, as it is going down. So finally this mg, so we can write mg minus ma, that is equals to your r. So finally this r value is equal to m into g minus k. So the weight now changes. Initially the actual weight was r equals to mg. That is what when the lift was in rest, I have already said the actual weight. And now the weight changes, the weight reduces by the ma times, right? So mg minus a. So this is now our apparent weight. So the weight machine doesn't read the actual weight, it reads the normal reaction force. That is the force which is acted on the object by the weight machine. Weight machine doesn't read the weight, it reads the normal reaction force. So it becomes the apparent weight. when it goes down. Now, I'm going from 8th floor to the 6th floor. So how this value is going to be changed? Let us observe that. You can understand it all automatically comes back to 206. Okay, but still we are going down. We have not reached to 6th floor yet, and it has become equal. That means whenever the velocity of the lift becoming equal, whenever it is reaching from the 8th floor to the 6th floor, so in between this journey, the velocity becomes equal. Initially it was accelerating whenever it has just started from rest. So initially the velocity was 0. It starts with some motion, with some velocity, with some acceleration. Then the velocity remains constant, and it finally comes to 6th floor, and the lift becomes stop again. Okay, so you can understand the change again. The change you can understand again, which is 206. So it becomes constant. So whenever the velocity is constant, that means acceleration equals to 0. So in the previous formula, that is r equals to mg minus ma while the lift was coming down. So you can take this acceleration as 0, and r becomes equals to mg, which was same as earlier, right? Now what happens whenever the lift is about to stop on this 6th floor? Now when it is about to stop, you can understand there is a certain change in the weight again. So the weight increases. The weight actually increases. As you can see here, it reaches almost to 221, pretty high value. So it almost reaches to 221. So whenever it is about to stop, so it has started its motions from 8th floor, about to stop in the 6th floor. So just before it stops on the 6th floor, the velocity decreases, right? So whenever the velocity here was constant, it has initial velocity was 0, starts with some acceleration, then velocity becomes constant in between, and then the velocity gradually decreases to stop at the 6th floor. So the acceleration becomes negative, right? So this acceleration becomes negative. And whenever this acceleration becomes negative, so here in this example, r equals to mg minus ma while downward motion. So as a becomes negative, so this value, this negative sign becomes positive, and this r increases. So our apparent weight will increase. This value of the weight will now increase. That is shown over here in this example. That is here in this example, almost reaching to the value of 221, right? Now whenever it goes up, starting from the 6th floor to 8th floor again, see what is going to happen. The weight increases in this case, right? The weight increases in this case, almost reaching to the value of 210 almost. As you can see here, 214. So whenever the lift starts motion upward, draw it again. Now the lift is accelerating upward. So from the 6th floor, now it is going to reach to 8th floor again, right? So it's just start with some acceleration. Here the initial velocity of the lift is 0. Okay, so this object will have two forces, one the normal reaction force, and mg is acting downward direction, and the person standing outside, that is in the inertial frame of reference, so with respect to that person. So how I can write down the equation of motion? So now r is going to be greater, so r minus mg equals to ma. So we get r equals to mg plus ma. Now the reaction force, as you can understand, normal reaction force value increases. That means the apparent weight also will increase. That is being shown over here. You can understand the value increases. So this is how the lift motion works. Thank you for watching this video.